take safety really seriously because I do have to hand teenagers fire and acid. Okay? The safety program we start off with is three-pronged. First, I teach you the safety rules. Okay? Then you agree to this, your parents agree that you're going to follow the safety rules. And then you take a safety test that shows that you know how to be safe. And then every time we do a lab, I talk about the safety implications of that lab. It's not one, I'll do a general one at the beginning, and then there's specific ones for every lab we do. Okay? So because, remember, the extra ones just put in the back. I'll come get them later. We'll just leave them in the back. Because if somebody does get hurt, my defense is going to be, I taught them. I taught them how to be safe. They agreed to be safe. They knew how to be safe. And I reminded them to be safe. They got hurt. It's not my fault. You can't have my house. Really can't. It's actually, that's why I go through the procedure. The reason why safety is important is so the real reason we do this is so people don't get hurt. Okay? And I have had, the most serious injury I've had in my class so far was I had a student who was heating something over a Bunsen burner, and it got, and the stand got bumped, and the thing he was heating fell, and he did the instinctive thing and stuck his hand out. Okay? Just instinctive things fall, you reach out to catch them, and what he caught was glowing red metal. And he got a little second-degree burn on his hand because he didn't hang on to it for very long. Okay? But that's the most serious one. Again, it's an accident. Accidents happen. We want to avoid the impact of accidents and make sure they don't permanently damage us. Right? That's the goal here. So, the teaching one, the way this is going to work, is the reason why I gave you that thing with the blanks is this: you're going to turn that piece of paper in as proof that you that I taught you. Right? It's going to be my proof I taught you. So then we'll talk about. Then later on we'll take the safety test, which will prove that you knew it. And I'll have a safety agreement that proves that you agreed to be safe. Okay? So that's evidence for me. Okay, notice it's got blanks. Okay, it actually helps your learning if you try to fill in the blank before I put the right word in. Whether you're right or wrong, it helps you think of the word ahead of time. Does that make sense? Okay, so while working in the science laboratory, you will have certain important blank that do not apply to other classrooms. What do you think fits there? Okay. Tempted to put the word rules there because it's safety rules, but they didn't pick rules. They picked, because rules implies that I am making you do this. Okay? And we want to make the emphasis that it's your job to be safe, not my job to make you safe. Right? So they use the word responsibility. See, I put in that word responsibility changes the focus. It's your job to be safe. I can't make you safe. Okay? You'll be working with materials and apparatus. Apparatus is just the equipment, which if handled carelessly or improperly have the potential to cause blank or discomfort, harm, injury, or discomfort to someone else as well as yourself. Because you're responsible for you and you're responsible for the people around you. Okay, I want to let you know the second statement, even though I got it straight from the state of California, is wrong. It's not true. And what's wrong is the prepositional phrase, if handled carelessly or improperly. You can handle things carefully and properly and still get hurt. I cannot make it 100% safe. The example I use is I had a student who was heating some water to boiling in a beaker over a Bunsen burner. He needed to remove that beaker, so he grabbed some tongs, grabbed the beaker, picked it up, and the bottom of the beaker stayed. And the top of the beaker came off and all the boiling water came flowing out. Did he do anything improper or careless? No, he did nothing improper or careless. He used the right tool. Didn't you picked it up safely? Could he have gotten hurt? Yeah. Didn't get hurt because he was wearing the apron, so the water ran down off the front of him, so he didn't burn the front of him. And when it ran down on closed-toed shoes, so he didn't burn his feet. Okay? So we try to make it safer, but if he'd had his back turned, or if his lab partner had a back turned, apron doesn't cover your back. They could have been hurt. So I can make it safer, I can't make it safe. Make sense? Science laboratory can be a safer place, put an R there, in which to work if you, the student, are foresighted, alert, and cautious. What the heck does foresighted mean? Does it mean you got goggles on, so you got 4 eyes? No. Foresighted. Okay, well, just break it down. Sighted, what you see. For, as in before. Okay? What you're going to predict, what you're going to see. What do you expect to see happen? Before you pick up a beaker of boiling water, have a plan of some place to put it down. No, you laugh, but I've watched it happen. They pick up this hot thing and then they look and they're holding a hot thing with no clear space to put it down. Foresighted, think ahead. We want your brain engaged. Violating any of the following regulations will result in you being suspended from class or permanently removed from the class. The difference between suspended and permanently removed. Suspended is I say, you're not wearing your goggles, you're going to sit down and get a 0 on this lab. Okay? That's suspended. So permanently removed is I go to the counselor and say, this person is dangerous to themselves and others. We need to get rid of them. Nobody wants to be around them. They're going to take them out. Okay? You want me to get rid of the people who are dangerous. Okay? Hey, then the first rule, it doesn't say a, it says an blank must be present during the performance of all laboratory work. So it's and, so it can't be teacher, so it's got to be instructor. Say, well, of course, there's always going to be a teacher in the room. Well, could be that somebody calls me out in the middle of a lab, or we run short of a chemical that I have to go down the hall and get, right? Or you could be making up a lab before or after school and I get called out. In any of those situations, if I'm not in the room, I'm going to tell you to move away from the lab. I'll be back in a couple of minutes. You should have the safety expert in the room where the unsafe stuff is happening. Okay? Report any accident to the blank immediately. Yeah, you would think they picked instructor, but no, they aren't consistent. They picked teacher this time. Why they switched? I don't know. Reporting accident to the teacher immediately, no matter how blank, including reporting a skin burn, scratch, cut, or corrosive liquid on skin or clothing. What's that second blank? No matter how. Yeah, you want to put severe in there, right? So, but if you put severe in there, that means you're looking for severe things. So they picked the opposite. No matter how minor. See how that changes the focus? Okay. So the littlest thing, tell me about. Most often I'll say it's okay, or put it underneath running water for a few minutes. That will be my answer most of the time. But let me make that choice. Okay? I'm the professional. Prepare for each laboratory activity by blank all instructions before coming to class. Well, what can you do with the instructions before you get to class? You can read, or you can read them. So reading all instructions before coming to class. Follow all blank implicitly and intelligently. Follow all what? Actually, they pick directions. I don't know why. And again, here's another word, and it's a word that people don't have any problem with intelligently, but they have problem with the word implicitly. Okay. What does implicit mean? Okay. Well, the root word is imply. So do what the instructions imply, not just what they say. If it tells you to pick up a beaker, it implies that you're going to pick up a hot beaker. It implies that you're going to pick it up with something that's going to protect your hand. I mean, they want your brain engaged when you're doing this. That's what they want. So redo what it says, but do what it means. There. Implicitly and intelligently. Okay? Make note of any modification in procedure. Your second period. First period's already done the lab. I know what didn't work first period. If I tell you to modify it, it'd probably make it safer, but probably make it work, right? So we may have to modify it so my oral instructions outweigh what was written ahead of time. And we'll talk about the lab before we do that, because first period tried it, and we found out what didn't work. Okay? So if I change the instructions, you should probably write them down so that you don't forget to do them. Okay. Any science project or individually planned experiment must be blank by the teacher. Approved. Okay. They didn't say supervised because sometimes teachers ask you to do stuff at home. But it may be surprising to you to say that if you went home and you did an experiment timing how long it took salt to dissolve in water, and all you did was put together salt and water, and you handed that in to me, I wouldn't take it unless we had talked about the safety of putting salt and water together first. You say, well, I'm not going to hurt myself with that. You don't get to judge safety. I do. And here's why. A few years ago, a student for his physics class built a potato cannon, which is we built out of plumbing pipe. And he built himself one off, following instructions on the internet. He fired it, it blew up in his face, sending shards of plastic into his body and burning him all over the place. Okay? He sued his physics teacher because he said, I was doing it as a project for my physics class. And the physics teacher said, whoa, 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 whoa. I knew nothing about a potato cannon. There's no way I would have approved a potato cannon. And the student said, well, last semester I did a different project and turned it in, and you never talked to me about that one. So I could reasonably assume it was okay for me to pick my own project and not talk to you. And the court agreed. It set the precedent by not talking the first time when what they did was safe. So at the second time, he got hurt, but he still thought he was working first class. Okay? So that's why if you're talking about if you want to do an experiment where you're going to put salt in water, I need to tell you we'll talk about the safety of salt in water first. I'll probably be talking about the glass. Make sure you're not going to knock that glass over someplace. That's the dangerous part of the whole thing, right? But it's as simple as that. I need to know how we try to do it safe. It's not that I don't want you to do things. I want you to be able to do things safely. One of my students came up to me and said, for my project, I want to do a report on high explosives and the reaction rates of high explosives. I want to blow stuff up. And I said to her, how can you do that safely? I mean, it was interesting. There's a reason why she wanted to do it. I couldn't do it safely. How can you do it safely? And the answer was, her father was on the bomb squad. She had access to the range and the materials and the safety expertise. She could do it safely. She did a project that involved blowing things up because she could do it safely. So it's not about limiting what you can do, it's about keeping you safe. Okay. Use only the materials and equipment blank by the instructor. You want to say provided, but sometimes teachers ask you to bring things from home, right? So authorized is what they picked. They got to make these as general as any situation, so because we don't want to say you have to get provided, or you add in another rule that says the teacher can authorize or approve. Inform the teacher of any equipment not working properly. There's a blank there, but it doesn't seem to be any. That's a complete sentence. Why is there a line there? I must want to modify that sentence. What do I want to modify? I want to modify the time frame. Don't tell me on the way out the door, oh, by the way, mine didn't work. A, your lab probably didn't work. B, you might have hurt yourself. So as soon as you notice it's not working, let me know. Clean up any non-hazardous blank on the floor or workspace blank. Okay, clean up any how do non-hazardous things end up on the floor or workspace? They spill. So it's a non-hazardous spill on the floor or workplace. Again, a complete sentence. But we want to modify it with the time frame immediately. So if you spill water on the floor, wipe it up immediately. Okay? Why? How is water on the floor going to hurt anybody? I don't know if you know anything about these floors, but when they get wet, they get really slippery. So they step in the puddle, they slip, and their arm goes waving as they catch themselves, and they clear the whole desk out. And every chemical that's on that lab table is now flying at their lab partners. You can see that happening, right? Or they don't wave their arms and they fall and their head catches the corner of this desk. And I can tell you, these desks hurt when you run into them. Okay? That's how a non-hazardous spill can become a hazardous spill. That's why you clean it up immediately. Okay? It's about people falling. Oh, I know what I forgot to mention. All of these rules are failure analysis. That means, hey, somebody got hurt in a lab. How can we stop that from happening again? It's just like how they make airplanes safe. Every time an airplane crashes, they go out to find out why it crashed, so they come up with a way to figure out to stop other planes from doing the same thing. It's called failure analysis. That's where these rules came from. These rules came from somebody getting hurt. Wear appropriate blank as directed by the instructor whenever you're working in the laboratory. And the next thing starts off with safety goggles. So we must be wear appropriate eye protection. Safety goggles must be worn in the must be worn during hazardous activities. And then they tell you what kind of hazardous activities we might have to worry about, like caustic or corrosive. The caustic and corrosive means they eat through things. Okay? You don't want the things that you can eat through going through your eye. Heating of liquids, hot drops in your eye, not good. And any other activity that may injure the eye, for us the rule is if there's glass out, you'll have goggles on. Okay? Why such emphasis on eyes? Because the eyes are the thinnest place between the inside of our body and the outside of our body. Thin enough that light can go through them. And eyes don't heal. Okay? So they're easy to injure and they don't heal. We really need to protect them. Okay? So you'll be wearing safety goggles. Okay. Safety goggles, they look like this. When you first put them on, you're going to go, and then about 15 minutes later, you're going to forget you have them on. It really happens. People don't believe me until it happens to them, but somebody's going to walk out with goggles on. You're going to forget. Okay? Happens every year. No, you don't get to take it with you. No making a fashion statement. Okay? Okay, this is wearing goggles. This is not wearing goggles. This is not wearing goggles. Okay, the test For whether you're wearing goggles, is the Three Stooges test. Fingers go in the eyes, you have the goggles on wrong. They're designed to seal all the way around, so if there's a splash, it doesn't go into your eye. That's why we don't just wear glasses, because the glasses don't seal around. Make sense? They do have air, these little things are air vents, so they tend to fog up a little less, but you can't splash in because the air's got to go around in circles to get through. If they steam up, and they will, step away from the lab area, take them off, they'll unsteam and then come back. That make sense? And so wear goggles. I wear them all the time. When in college, I had 2 4-hour labs, so I'd wear them 8 hours a day. By the end of the day, I would really forget that I had them on. Like, oh, they're there. Okay, splashes and fumes from hazardous chemicals present special dangers to wearers of contact lenses. Okay. Therefore, students should preferably wear their regular glasses inside splash-proof goggles when appropriate during all class activities, or purchase personal splash-proof goggles and wear them whenever exposure to chemicals or chemical fumes is possible. If you want to buy your own, talk to me about what the safety specs they have to meet, because it's not just they've got to meet a safety spec for sealing and one for impact, that this plastic has to be able to stop flying shards of glass. So there's an impact test for this too. Most people don't. Okay, but let's talk about the special dangers. Okay, why the heck are contact lenses give us special dangers? So, see, you get to see the quality of my artwork. Okay, so this is a side view of your eyeball. Okay, and a contact lens is actually misnamed. It goes right over the pupil, but they call it a contact lens, but it doesn't actually contact the eye. It rests on a layer of water. And fact is, the contact lens is mostly water. It uses water to give it that structure. Okay? Talk to anybody who's got contact lenses. If their eye dries out, that water's not there, they can feel the contact on their eye. They leave their contacts out on the counter and don't leave them in the solution. They find a little wadded ball of hard plastic. Okay? And it's that water that's the dangerous part. Because if you splash with contacts, the splash gets behind the contact into that water that's held right up against your eye. That's a special danger. If you rinse your eye, it's not going to rinse the water behind your eye contact. Right? So it holds the chemical against your eye. That's the special danger. Say, well, is hitting chemicals, we got bigger problems, right? Some splash big time, and we still would have to deal with it differently. But it's about getting your hands. Yeah. Good. Okay. Some of the rules are common sense. Never carry hot equipment, or dangerous chemicals through a group of students. Words I don't want to hear. Boiling water coming through. I want to step back. I've got some boiling water I'm going to spill all over you. Okay. That fits into the duck category, right? That's a common sense one. Okay. Check blank and equipment instructions carefully. Labels. Okay. Most common mistake made in lab is to pick up the wrong chemical and put it in the wrong place. All the chemicals will be labeled. You should read the label and make sure the stuff in your hand is the stuff you're supposed to be using. Don't just assume, because it may be unsafe, and it definitely will make your lab give you bizarre results. Okay. Be sure the correct items are used in the proper manner. So I said that somebody picked up a beaker with tongs. There are tongs called beaker tongs that are designed to pick up beakers. There are tongs called flask tongs that are designed to pick up flasks. There are tongs called test tube tongs. They're designed to pick up test tubes. Use the right one in the right way. Do not try. What I find is people try to use test tube tongs to pick up a flask, and it won't hold it. They're not designed that strong. So the right piece of equipment, used the right way, and I will demonstrate how to use any new equipment before you guys have to. Be aware if the chemicals being used are hazardous. I'll tell you. I will tell you what the hazard is of every lab you're about to do. Okay? And what's the dangerous chemicals and what it could do to you. Okay? Know where the safety data sheet is. Here's the safety data sheet. Right here. It's a disk. Okay, in a safety data sheet, every chemical has a safety data sheet. And it tells you what the dangers of it are, what to do if you're exposed to it, what to do if it catches on fire, how to clean it up. Okay? And every chemical has one. I was at a workshop for chemistry teachers in a hotel ballroom, and we were working with some electronic probes, but we needed water, so they gave me a bottle of water. And attached to that bottle of water was the safety data sheet for water. Fatal if inhaled. Call it drowning. It tells you how much water you have to drink before it will kill you. There is a number. Right? So they tell you the lethal dose that will kill half of the people. If you drink this much, half the people will die. Lethal dose 50. Okay? And if you drink enough water, it makes so your kidneys don't function. Okay? And you die. It tells you every possible danger, right, of that chemical. So just because it has a safety data sheet doesn't mean it's really dangerous. Every chemical has a safety data sheet. Okay? And I will make sure that you are informed of what the hazards are of every chemical that you're dealing with. Never taste anything or touch chemicals with the hands unless specifically instructed to do so. Say, this is the silliest rule ever. Who would ever taste chemicals? The answer is, it used to be standard laboratory technique. Before we had a bunch of fancy lab tests, our only chemical detectors were taste and smell. That's what taste and smell are. They're chemical detectors. And our tastes are divided up into two categories. Taste that tell us something is bad, and taste that tell us something is good for us. So we've got salty. Salty is good for us. We need salt. Sweet. Sweet is good for us. We need sugars. We need carbohydrates. Sour. Sour is what acids taste like. When you taste sour, that's your body saying you are taking an acid in. Acids taste sour. Bases taste bitter. Bases and acids tend to be poisons in nature. So you'd want to avoid them. So we've got two tastes that tell us these are things you don't want to eat, and two that tell us these are things you do. So sour and bitter are acquired tastes. But nobody has to acquire a taste for salt or sugar. Does that make sense? Okay. How far does this go? Well, I said standard laboratory technique. Did you know there's two kinds of diabetes? Diabetes mellitus and diabetes insipidus. Okay? The word mellitus means sweet. Insipid means bland. So diabetes insipidus has bland tasting urine. Diabetes mellitus has sweet tasting urine, because that's how the doctors detected it. You tasted the urine. It was common laboratory technique. Unfortunately, we'd had some downsides to this technique. Things like, ooh, tastes like almonds. That's cyanide. Lost a lot of good chemists that way. That's why we don't do this. Okay? But that's why they put the rule in there, because it used to be standard lab technique. Okay? Test for odors of chemicals by, the technique is called wafting, good job, but they describe it instead of labeling it. They say waving your hand above the container and sniffing cautiously from a distance. So if you want to smell something, bring the smells to your nose, not your nose to the smells. Okay, because we got some ammonia. You'll be able to tell it's ammonia if you do this, but if you do this, you will clean out your sinuses all the way to the bone. Okay? So bring the smells to your nose, not your nose to the smells. Okay? That's wafting. Eating or it says eating or drinking in or from laboratory equipment is permitted. No, that's got to be wrong. It's got to be eating or drinking in the laboratory or from laboratory equipment is not permitted. They make coffee cups that look like beakers. I'm like, what, you trying to kill chemists? Pick up the wrong beaker? It's not quite coffee. Okay. When heating material in a test tube, do not blank into the tube or point it in the direction of any person during the process. Okay. Do not look into the tube. They don't mean don't look at the tube. They mean don't look into the tube. Okay? So you're heating a test tube. You don't want to look down the throat of the test tube. You want to look from the top. Well, first of all, you actually want to aim it sideways a little bit. Okay? What they're worried about? Steam. Okay? If it's got a little bit of water in that test tube you're heating, that steam is going to form at the bottom and push the boiling hot water out the top and whatever chemicals happen to be with it. So if you heat it and look at it like this, you're taking a shot that you're going to shoot boiling chemicals in your face. Okay? So what you do is you aim it, don't look at your face, you aim it at your lab partner. No. People across the table from you. You aim it at the wall. Okay? The wall is less harmed by flaming poisonous liquids, or boiling poisonous liquids. So aim it at the wall. You ever pour blank into bottles or exchange stoppers or bottles or lay stoppers on the table? That is, never pour reagents. They use the word reagent. Reagent is just another name for the chemical that you're using in that lab. The agent that reacts. The agent that reacts, that's why they call it the reagent. Okay, yeah.
I think the next one
Which?
says use a blank pipette filler.
Oh, okay. I got rid of that because nobody was, okay, so a pipette looks like a straw, okay? So use a pipette filler, never the mouth. Use a
When measuring or transferring.
use a mechanical pipe filler, never the mouth. Because they look like, pipettes look like glass straws that are measure very accurately, chemists got lazy and would try to suck stuff up on them like a straw. But you lose a lot of chemists if the chemicals go too far. Okay. We got little pumps that suck the stuff up for us and put it out for us so you don't. So my pipette one, I thought I took that one out. Hey, the reagents one. The reagent one is about contamination. If you do any of these things, exchange stoppers, lay the stoppers on the table, or pour reagents back into the container. So you poured it in one container, you got too much, so you pour the extra back because you're trying to be a good human being. The question is, we don't know what you're pouring back. There could have been something in your beaker that's a contaminant, and it may not affect your lab, but the next person who gets that reagent doesn't know exactly what it is. So what you contaminate it with may be a catalyst, make their reaction go out of control. So the reagent bottles we want to keep so we know exactly what's in there. So if you pour it out, don't pour it back. If you lay the stopper on the table, you're going to pick up whatever's on the table and put it back in the reagent bottle. We don't want that. You change stoppers. Whatever's on the bottom of that stopper is now going to be in that other bottle. So that's about contamination and about how it can make contamination make the next experiment go violently wrong. Hey, When diluting blank, always pour acids into blank, never the reverse. Well, heck, you can take this one apart and figure it out. So when you dilute something, how do you dilute something? Add water to it. So always pour acids into water, never the reverse. But what are you diluting if you're adding water? Well, you're diluting the acid. So in diluting acids, always pour acids into water, never the reverse. Okay? So there's a couple of reasons for this rule. One of them's logical, the second one is chemical. Okay? The logical one is you want to have control when you're pouring of the dangerous stuff. Okay? Because if you pour too fast, the container could fall over. And if that container was full of the acid, then you have concentrated acid everywhere. You want the one you can control over. That's the physical one. The chemical one is this, that when you put acids and water together, it gives off heat. And it can be enough heat to boil the water. Okay? So what would happen if you do it in the wrong order? The first drop of water goes into a container full of acid. All that acid tries to dissolve into that drop of water. With lots of heat, that drop of water turns into a bubble of steam, spraying concentrated acid back in your face. Because you get that little drop of water, the first drop of water gets a lot of heat. If you do it the right way, the first drop of water into the first drop of acid into the water, that first acid dissolves into all that water. It's not going to be able to give enough heat to boil all that water. Okay? It's about how much water is getting the heat. Okay? Because if you do it in the wrong order, you're taking a chance on it spraying back in your face. How do they know that? It happened. Okay? These are all failure analysis. So this one you just have to memorize. Okay? And I would say that the way I memorize it is alphabetical order. A to W, acid to water. If you do it in alphabetical order, you're doing it the right way. And they don't say it here, but the same rule applies for bases. For the same reason. Okay? Same rule, same reason. Wash your hands as necessary and wash thoroughly at the blank of the laboratory period. They didn't want you to write a 3-word one, so they didn't put end, they put conclusion. You don't want to take this stuff with you when you go. Seems pretty reasonable, right? This is not what you want to have for a between-period snack, whatever you had on your hands. To treat a burn from an acid or alkali, alkali is another name for base. Okay. Wash the affected area immediately with plenty of running water. Immediately, and plenty of running water. The eye is involved, irrigate at the eye wash station without an interruption for, how many minutes do you think? Minute or two, 2 minutes, 3 minutes? 15 minutes. We want to make sure that stuff is gone. So I gotta get some more. I'll be back. And report the incident to your instructor immediately. Don't start that yet. We're still doing this. Okay. Okay. So, I told you that if you got something on you, my most common response was going to be put it underneath running water. We'll talk about the locations of all the safety equipment next, but the eye wash station's here. 15 minutes is a long time. If you've got contacts, somebody's going to have to pry your eye open. Well, actually, whether you have contacts or not, you're going to have to pry your eye open. So you won't be able to use one hand and this. You're going to have to ask for somebody for help. Probably going to ask somebody for help to get to the eye wash station. You're not going to be able to see things very well. You got chemicals in your eyes. So be nice to the people around you. Maybe they'll take you to the closest eye wash station. Okay? Then you're going to have to hold it open. Well, and somebody's going to ask you about contacts, and if you got contacts in, that contact has got to come out. Otherwise, it's holding the alkali or acid up against your eye. Okay? That make sense? Okay, we'll continue from here tomorrow. We'll get this stuff knocked out. Looking at probably a test on safety stuff Tuesday of next week. The safety test is where I've got it scheduled. Okay? I usually take almost 3 days to do this, because this is different than you've had safety rules before. It was always just read to you. I'm trying to tell you exactly why every one of those ones is there, what they were thinking about, because you need to be serious about safety. Okay, so the math review that's due tomorrow, okay, it should be simple stuff. It's order of operations. It's dealing with variables, solving for x, it's Algebra 1 stuff. Yeah. You don't have to show any work. Okay. I just want to see if you can do it. There's some scientific notation. You may not have any experience with that. Again, you've experienced it. You may have forgotten it. I need to bring that back. Okay. And again, we're looking at calculators probably Thursday of next week. A calculator that says EE or EXP and has a word log on it someplace. It's got a log button. It'll do the job. The word you want to avoid is multiview. Multiview is bad. Multiview is bad. Homework shouldn't take any long. It's just I'm looking for gaps, things I'm going to have to address as we're teaching these things. Because you don't want me you do not want me spending time having to teach math that everybody already knows how to do, right? So it's a matter of me just organizing my stuff. Questions, comments, cares? Have a good day.